talk shop for next week, and see what if we must not maybe change dates for next week and the week after. So just think about it. I will post it on our WhatsApp group as well. But I was nearly thinking if you guys can try your next week, your first attempt, maybe the Monday or Tuesday, you can always send me some screenshots, and then we can maybe have a session on Wednesday and go through some of that. The same nearly for the week after. So think about that a bit. I think that Carl, you quickly thought about that, but I think that might be the best way to prep you guys for the last two sessions. So I will ask just on the group again, but it feels like if we can do it later in that week for both, then I think we can have a nice prep for your last two big assignments. So definitely we'll ask on the group. Okay, so tonight, this was a strange topic nearly to go through, because it looks at. Oh yes, let's quickly check where is that attendance register. I think it is that one. Okay, so topic 6 on application of differentiation. Yeah, wants to make sure. um, and what how they nearly discuss this topic is, we're going to go through a few things that you guys would have covered in other subjects. So we're going to look at more total cost, fixed cost, variable cost, marginal cost. Then we're going to go into the derivatives and slopes around that. And then the last part of the session will be on marginal profit. So nearly we could have actually done derivatives first and then look at the application, but we go the route as how it is in your study guide, and then from there we can just go into a few examples as well. So I assume out of your economics or one of the other ones, you would have looked at the things around total cost, that is looking at your fixed cost plus your variable cost, and then normally in a question they would tell you the fixed cost is 5,000 rand, or they would use wording like, how do you, or they would use, okay, ECS. That, I think that is economics, I think, Kyle, if I can remember that. So they would normally in the question say, the fixed cost to create or to make certain things or to manufacture will be an amount, and then normally what they will add to that question is to say, and you make a number of units that will cost you 50 Rand per unit or something like that. So normally we will look at it from a point of view that you will have a total cost that is normally a fixed cost plus a variable cost. And that is normally an amount for fixed cost, and the variable cost will be a cost per unit. So it normally, and let's now not do it in stats terms, let's do it in the terms of economics. So let's say it was 50 times Q, which is the quantity of a product. So that is nearly how your total cost function would look like. Then why it's important to look at this is when we get to the marginal cost and marginal profit, there's a few extra things that we will need to add to it. And when we get to derivatives, we nearly gonna work with that marginal cost or with a total cost and create a marginal cost by using derivatives. So that's nearly why they first introduced the total cost. Again, nearly the definition around that. That's why we're going to look at the marginal cost element, and then from there we're going into derivatives, because we're nearly going to derive from those equations that we get to your marginal profit, so, and your marginal cost. So let's quickly look at some of those examples and definitions. Then we'll look at all the derivatives kinds of equations and definitions and theorems. And again, since you guys are writing your assignments open book, I've added some of those definitions that you now don't need to go and page through your study guide. It is nicely summed up in one of the slides. Okay, so going into marginal cost, and again, I don't think there will be really any definitions of this in your assignments, but if there is, then this will cover it. But how we look at marginal cost is it's defined as the cost that results from one unit increase. So if you look at the formula, it's nearly to say that change in total cost, change in quantity. So this would have also been, and I think we did that in, what was it, study unit 3 or 4, when we also looked at straight lines and things like that, where we looked at slope. This is basically a slope. So again, the slope normally is change in y over change in x. So marginal cost is change in the total cost, change in the quantity. So very similar principle that we're going to use here. And that's why sometimes when you're going to look at things where they want you to work out slope in this instance, that is actually what you're going to do. You're going to work out the marginal cost. So again, just a bit differences in wording, which might, when you get to your assignments, they might use those differences in some of the questions. So again, so if you look at marginal cost, that can be defined as 1 unit increase in the production rate. The cost of producing an additional unit is also basically marginal cost. So things that they can look at is it decreases as the volume of production increases. So again, one need to just check where the change is. But when we get to example, that will be more clear. Then I think the other thing that is important, again, if you guys were, if it was closed book with definitions, then it's something different. But with being open book and you can use things, the one thing that is just important with marginal cost, it only influences the variable cost, and not the fixed cost. And the reason why is, if you look at the marginal cost formula, so change in total cost, which is variable cost plus fixed cost. But look at the one below, change in quantity. So if we produce 10 or if we produce 20, your fixed cost will stay the same. So the one that actually is being influenced is the quantity and the variable cost. And that is nearly so where marginal cost then comes into play is nearly to get the balance that at a certain marginal cost, if you start increasing, then your quantity, then it becomes maybe negative, and you are not making as much profit as you could. And that's why it's also important that we nearly at the end link it back to a profit, where we will look at total revenue minus total cost. That also was nearly in that economics one subject that you would have done as well. So that nearly is looking at marginal cost. So marginal cost is just to say, if I increase the production by 1 unit, what is the change in cost? It can also be, what if I change the quantity by going less? How will that also influence the cost? Okay, so it can be an increase in quantity, it can be a decrease in quantity, it can just never ever be a negative quantity. And again, going back to your economics, when you guys did it, you can't produce negative quantity. So if we talk about you need to make gates or chairs, or you can't create a negative chair. Um, maybe in ESCOM environment or something like that, but not in real life. So you can't create negative units. So you can only have a positive quantity always. It might be that in instances you only, or you don't produce anything, because when you produce it will lead to nearly you not making a profit, but never will it be a negative. Okay, so that's looking at the nearly your total fixed variable cost linked to marginal cost. Then if while you're going through the study unit, then suddenly they introduce derivatives. And so what I thought was, okay, but let's just have this list of derivative rules that you might come across, because it might be that they go back to the fundamentals of derivatives and just ask you derive um, from this formula. And it might be something like I've added here, that they just ask you to do certain things, where they tell you this is the function, you need to work out the derivative of that, and so it might be something like that. So that's why I think it's still important that we look at the rules. But again, we have it, so it's not. Please don't go and study this or anything. I'm going to share this again tonight, so you have it. And again, there might be probably more rules here than it might be in the book, but this covers everything. So it might be that they ask it in such a way, or it might be that they ask it in a way that you now need to go and calculate the total cost, fixed cost, variable cost, that you need to go into a profit function, and then maybe you need to work out the derivative. So again, it might be that they change it up a bit. Um, yeah, so what this is, just so this let me so this is the, let's call it the pure mathematical way of writing it. So how we would normally write it is the derivative of x. So that so this is the pure mathematical way to write the derivative of x, but you will see we will nearly write it every time as the function, let's call it copy or hat or whatever that thingy is, with a x. So that's nearly how you will seldom, and if you look at this again, you will seldom see it being written as d over dx. So it's just the derivative of x. So you will very seldom see this. You will most likely see it as the function that's a derivative of x. Okay, so those two things are exactly the same. So what I thought was I would show you this just in case, in the exam, or not in the exam, but in the assignments, now suddenly they do the d over dx. So we just cover both bases nearly. I hope they use this terminology, because this is the normal terminology, but I've seen too many things with with um, some of these subjects. So let's just be careful and cover both. Okay, so again, you guys don't need to go and study this up. We will go now through a few examples of this. But it will also be great if you guys can share some of the things that you're getting this week in the assignment, because it will most likely be, in any case, in your assignment of next week and in your last assignment. So at least with 5% this week, not too bad. But it will give us a very good indication of what will be happening in your assignments for the last 2 weeks. Okay, so all the derivative rules that we will cover, and then from that we go into marginal profit. So what I've gave you guys here is to say, so the notations that we will see, and Carl, that is nearly why I showed the other one as well, is so marginal cost. To get marginal cost, you basically take the derivative of your cost function. So that will be your total cost function. Marginal revenue, you take the derivative of your total revenue function. Marginal profit, you take your derivative of your marginal profit function. So when we need to get our marginal cost, we will say total cost, the derivative of that. When that is marginal. So then your marginal revenue is basically your total revenue. So that will be, you will get your marginal revenue from your total revenue. You will get your marginal cost from your total cost, and you will get your marginal profit from your profit. So that's really the linkages between what you guys will need to look at. So to get marginal profit, you're going to derive or get the derivative of your profit function. To get marginal revenue, derivative of your total revenue. To get marginal cost, the derivative of your total cost function. So what I also just included here is some of a function so that you guys can again see how it can be written in a different format. So I thought let's just put the marginal cost that might be with your marginal revenue, with your marginal profit. But here is the short code. So nearly anything that they might ask you along the line of the derivatives with all the different types of formulas is nearly covered on this page. And then also if they ask you nearly a definition, so marginal profit is the change in profit due to change on the number of units produced. It's also in here. So again, just it might be that they throw in the definition of total cost, total profit, marginal profit, those kind of things. Yeah, it will be interesting to see now with this assignment how they do that. So yeah, so please just share some of those questions. It would be just interesting and then good so that we can prepare for the two last bigger ones. And then if you need to test it at the end, your marginal profit needs to be equal to your marginal revenue minus your marginal cost. So that nearly again, there is always a way of testing the answer in certain things. Okay, so that is the nearly the definitions around it, the formulas that you will need to use. The reason why, and let's now move it into here so that we can see. So we're going to derive certain functions. So the reason why this is very important is that it might be that they give you a very weird formula. if it is only a total cost or something like this, it might be easier. So again, it will be nice to just get a feel of what types of formulas they might ask you. So for me, normally the ones that I think they use a lot is the power rule. And we're gonna look at a few of that now. The other thing that they also like to throw in is the rule about the constant. Um, so we'll look at that as well, because the constant rule will affect your fixed cost. Okay, so we will have the constant rule will definitely affect your fixed cost. So that might be the one that we also just need to look at. Then the other ones, I'm like, it, I can't see them always using it. The sum rule maybe, but if you go in the others, it is very difficult unless they give you, and now I need to think, did we ever look at log functions? That might be way back also. We might have looked at log functions and exponential functions. So it might be that they bring some of that in here as well. So once again, if any of those comes into your assignment, um, share it, and then we'll prep it definitely for the next big one and also for your last one. Okay, so let's just go through a few things. So and I've included this to do and show a few things that you guys can see how we work with some of the um, how we work out the derivative of the function. So what happens? So when we get the function and we need to derive from the function, if it is a function like this, x to the power of 5, what happens when we need to derive it is that 5 goes to the front. So whatever there was will go to the front. And what then happens with a 5, you will always subtract with a 1. So that's why your answer to that will be 5 goes to the front, 5 minus 1 is 4. Okay, so if my equation was this, what will happen is the 3 goes to the front, so 3 times 3 is 9. Then 3 minus 1 will give me x to the power of 2. Okay, so if we needed to, with this instance, do the derivative, we would have said, okay, 3 times 3 gives us the 9, 3 minus 1 gives us the 2. Okay, so that's going to be your whole process if you work in this format. So doesn't matter how the numbers look like. So in this instance, that whole thing goes to the front. So we will have minus 4 in front. Then, like I said, like we always do, we take minus 1. So minus 4 minus 1, let's just write the minus 4 over. So minus 4 minus 1 is minus 5. Okay, so again, same principle. If it was minus 10, then it becomes minus 10 minus 1, that will be minus 11. So the whole time we're following the same process. So the same with this. So 2 over 3, doesn't matter if it's fractions, if it is positive, if it is negative. What we do, take that to the front. So that's why it is 2 over 3 in front. And then minus 1. So here what they've already done is just to say, okay, we are working with a fraction. So 2 over 3 was there. So we can say, let's make it easier for ourselves to work with. And 3 over 3 is 1. So then it's just, they nearly skipped the minus 1 and went into minus 3 over 3 automatically. But when it is 2 minus 3 is minus 1 over 3. Okay, so again, that is how it will be. So doesn't matter if it's a positive exponent, if it's a negative exponent, if it is a fraction as the exponent, the process always stays the same. Take that exponent to the front of your formula, and then what you will do is exponent minus 1 will be the one that is left. Okay, so bit different, but tell me what will be x squared is equal to what? And you need to dig deep into memory of what we did previously. Perfect. Thanks, Carl. So remember, it is x to the power of a half. So now, much simpler if you have that, because now you know, oh, well, a half will go in front. Then it is a half minus 1, which is actually a half minus 2 over 2. So a half x minus a half, because 1 minus 2 is minus 1. So minus a half we will get. Okay, so that is, again, nearly the process that we will follow. The same, so we're going to go through all of them up until this last one, because the last one is just a few of those that are combined. So with this process, remember the 4 times what is in front. So we have 8x, and it is 4 minus 1. So it will be 8x to the power of 3. Okay, exactly the same process nearly. Okay, bit different, but follow the process. So 2 times what is in front, it will be minus 12. X to minus 1. Okay, so they basically have broken it up here already, but that is what we will get, minus 12x to a power of 1. And again, you don't need to write the 1. It could be taken away. So again, depending on what you will have as answer options, but they will normally not write it as x to the power of 1. They will normally leave it as x. Okay, so okay, so again, interesting one, 3 over 2. So again, let's follow the process. So 3 over 2 times 2 over 3, x 2 over 3 minus 1. Okay, so that leaves us that now we can simplify a bit. So 3 over 2 times 2 over 3 is actually 1. So 1x to the power of minus 1 over 3. Okay, so again, the same process. Whatever is the exponent, multiply by what is in front of the x, and then work with the rest. Okay, this one, I wanted you to split that out first, so to put 1 over 2. So 1 over 2 x to the power of 1. Okay, so that means 1 times that is minus 1 over 2 x, and then it is 1 minus 1, which is minus a half x to the power of 0. What is x to the power of 0? And now nearly your exponent rules. So x to the power of 0 is 1. So we have minus a half times 1, which will then give us minus a half as the final answer. Okay, so it can be that while you're differentiating, you might get an answer without the x. Okay, so the only time that will happen is if you differentiate x. So if that is x to the power of 1, wherever you differentiate that, that is when it will become only a constant. Okay. Then the last one. So the last one, how we handle something like this is to say, okay, well, we've now every time there was only one term that so we will differentiate that, we will differentiate that, and we will differentiate that. So we will need to do it 3 times. Okay. So 12x to the power of 2 to differentiate. 2 times 12 is 24. X, remember 2 minus 1 gives you 1. So we can keep it like that. Then there's a 1 there. 1 times minus 24 is minus 24. X1 minus 1, x to the power of 0. X to the power of 0 is 1. So basically, we would have just multiplied it by 1. And then plus 8 is a constant. So if we differentiate that, it just falls away. Okay, so when we differentiate a constant, it will just fall away. So it will disappear. And this is nearly important to know that, because remember when we work with total cost, your fixed cost is normally a constant. So it might be that when we get to the next 2 or 3 things we need to work out, that when we differentiate, looking at a total cost function, that the fixed cost will disappear. So it might happen if it is a simple formula, might not happen if it is, but let's look at that. So just keep in the back of the mind whenever, and that's why the constant rule that we always will differentiate any constant will give you 0. Sure. So it depends what your formula is. So if it is the the quadratic, yes, but if it is a straight line, then it might not be. So that's why nearly we need to check, Carl, what they give you. Um, because if it, so you could have, and let's just add a new slide. So you could have that your total cost is equal to, let's say that. So so that's your variable cost, that is your fixed cost. So if it is a straight line, that would have been your y-intercept. So for straight lines, your fixed cost is always your y-intercept. So that is nearly a way to look at it. If it is quadratic, then it will be the turning point. Okay, so just for the straight line, it will be your y-intercept. So your fixed cost will always be your y-intercept with a straight line. If it was quadratic, then it will be part of your turning point. Okay, so that's nearly why I said we must just be careful. So here as well, that 8, since it's quadratic, would actually have been more your y-intercept. So depending on how the formula looks like. Um, so what will create your turning point is the derivative of, so this would have been part of your turning point. So it's the y-intercept, not the turning point, but your first derivative will be nearly where you will get your turning point as well. Because this first derivative would be the line that goes through that point. Okay, so but I don't think you guys need to worry too much about that. But let's see what comes out of the assignment questions. But they might just ask you to work out the first derivative like we did, and you can see that is a straight line. So your first derivative of a quadratic function will always be the straight line that then will nearly cut through where it is going to be the turning point. Okay, so let's look at some practical questions. So those first things was purely to do with if I give you a function and you need to work out the derivative. Now they're giving you a few things. So now they tell you, and that's why they brought in the total cost, the total revenue, and those things, because they want you to now work out the profit function and then nearly what is the derivative of that profit function. So let's look at a factory has found that the total revenue from producing and selling X sound systems is given by your total revenue function. The cost is given by that. So you know nearly that your total profit will be your total revenue minus your total cost. Okay, so we could, as they now have done here, that is how we would work it out. So let's quickly check total revenue and let's put it in here. And I should have written it a bit smaller, but that's fine. Minus 100x plus 2,000 or 200,000. Okay, and then, so they ask us calculate and interpret the marginal profit when 5,000, 7.5, and 8,000 sound systems are produced. So let's first work out what is the profit function. And then when we go back, okay, so if we have our profit function, to get to marginal profit, we take the first derivative. Okay, so let's work out our profit function. So 0.02 x to the power of 2. There we have 100x, 400. So 400 minus 100x is plus 300x. And then minus plus 200. So it's minus 200. So again, that will be your fixed cost component. So what they could have done as well is to tell you, instead of giving you this formula, they could have told you, well, the cost is a fixed amount of 200,000 and you will pay 100 Rand per unit on labor cost or something like that to produce it. Okay, so they could have given you it in a sentence so that you nearly need to write down the cost function. So that could have been one of the, the differences in not just giving you it, but give you it in words. Okay, so we've got the profit function. Now we need to take the first derivative of that. So as we did previously, the minus 2 goes in front. So, sorry, the 2. So 2 times that is 0.04 x. Remember 2 minus 1, which will just give you x. And then there's 1. So 1 times 300 is 300. x1 minus 1 is x0. x0 is equal to 1. So it stays like that. And then the derivative of a constant is 0. So we could have said plus or minus 0. So that actually has no effect. So now what they want you to do is to say, looking at this is now your marginal profit function. So if my marginal profit function is 5,000, and I have a 0.04x plus 300, what will we get? So the minus go to that side, so 4,700. This is a very interesting one. Is revenue minus cost. That is very interesting when negative. X, so if we then want to calculate X, we will say 4,700 divided by 0.04 Yeah, so what I think it's gonna show, so x is equal to minus 117,500. So your marginal profit is for, so when you produce that amount, it's 47. So I assume if you now start changing it to 75, the 75 on this side, so it will be 7,200 if I subtract the 300 equal to 0.04x. So I assume that this might now become smaller or something like that. Okay, so it becomes larger. Okay, so we're only gonna, so what this tells us is, and exactly like you said, Cole, actually the profit function is negative. So already in there, and let's not say there was a mistake. That might actually be a mistake because in there already, because that's negative, it feels weird. But let's say, so what this means is that your marginal profit will go up by 2,500 for every extra 35, 36, let's see, 62,500. There's something in here that should actually be, I can't, that must be, I think there's a mistake in this one. Because, exactly. So X is the number of units. So I'm not, it feels like that is a mistake. Um, because if you sell 10 units, oh, sorry. Thank you. Thank you. Thank you. Thank you. I, thanks. I'm wrong. Totally wrong. Thank you. I read it as, I read that as marginal profit is, and not the other way around. Okay. Because, yeah, I would probably have taken me a few long minutes to work and see that out, because I was like already blaming the exam department here. Okay, so what I should have done is, okay, let's undo. Okay, so we have that as, that was the formula that we have. Don't want to rewrite that. So you can actually give a class. And what we will read, so please don't make the mistake in the assignments as I did. The number of sound systems is those, and not as I read it, the marginal profit. So number of sound systems. So thanks for that call, Kyle. So what will happen most likely now is, so we're going to use that one, And then let's use the 8,000. And we first keep the 7,500. So 0.04 negative times 5,000 is minus 200. Minus 200 plus 300 is equal to plus 100. Oh, thanks, LZ. um, cool. See, I'm making too many mistakes. I blame the booker for that. um, so so that is marginal profit when we had 5,000 was sitting at 100. So let's look at marginal profit when we do the 8,000. So one normally assumes that when you creating more stuff, um, you will you will make more profit. So create when we build or produce 8,000, we will actually make a loss of 20 Rand. So the more you produce, the less profit you will make. And at 8,000, so if it was 7,500, so if we put in 7,500, you would actually get minus 300 plus 300, which will give you 0. Okay, so what this tells us is when you produced 5,000, you made a profit. When you produce 7,500, what is it, break even? There's no profit for you. And when you made or produced 8,000, you were actually making a loss. Okay, so in this instance, probably much better to have only produced 5,000 than 8,000. Exactly. Exactly. So and I assume again, if you look at sound systems and if this was South Africa and things that we need to import versus labor cost versus all those, so that's where the economics comes in as well, nearly, where certain things you don't mind to produce a lot of, and other things, like you said, um, especially the ones with low profit margins. And that's why it's so important um, to be able to do these kind of things, and why derivatives in some instances has its value. Cool. So that was when we needed to do marginal profit. So we know marginal profit, we basically take um, your total profit and take the first derivative of that. Here, what they wanted us to do is to say, okay, but let's look at, and it's probably the total cost function. Um, so remember to get marginal cost. So they're not going to write it like this in the assignment for you nicely to guide you. They're just going to ask you work out what the first derivative is, or they're going to ask you, here's the total cost function, work out what is marginal cost. What they can also do is to give you both of these and then say, work out marginal cost, work out revenue, or marginal revenue, work out marginal profit. So it might be that they even give you all 2 or 3 functions, and you need to know nearly which one is linked to which one. Okay, but if we do this one, basically the 3 goes in front, so you will get multiply by 3, 3 minus 1, which will give you, and I'm just going to write it, x to the power of 2. Then the minus 0.8 times 2, because the 2 goes into front, 2 minus 1, which will give you, in this instance, x to the power of 1, which will be x, and then 40x. So remember, 40x is actually a 1. The 1 will multiply by 40, so it gives you 40. 1 minus 1, in this instance, plus 40, and then that fixed cost nearly sitting there, the 5,000 will become 0. Okay, so that will be now your first derivative, and then they ask you to work out what is the marginal cost, and not again like I assumed with the previous one. So again, just be very careful when you read it. What's the marginal cost when you need to manufacture 400 calculators? So we just put the 400 into this formula. So 0,0003 times 400 to the power of 2 minus, so 2 times that would have been 0.16 times 400 plus 40. Okay, remember this was already the first derivative, so don't forget about that 40 when you substitute the 400 in, because that 40 can make a change in the number of units. So 400 to the power of 2 gives you 160,000. If we multiply that by 0,0003, we will get 48. Then your 0.16 times 400. Just check this one again, because your marginal cost, okay, sorry, will be, and plus 40. I nearly wanted to subtract, so minus 64 plus 40 plus 48. So your marginal cost will be 24 at the production or manufacturing of 400 calculators. Okay, so let's just also check, and just, so the other thing just to check normally is in rand. So it might be that sometimes they tell you in thousands. So just check and be careful with what is in brackets and then what your final answer will be. So in this instance, perfect, it's 24. But if I set in thousands, it might be that they want you to write 24,000. So just, I've seen it in other subjects where they just, in that brackets, might say in thousands of rands. So just be careful with what is in those brackets and just apply it to your final answer. Because what will happen is if it was in thousands, there would be a 24 and there will be maybe a 240, 2,400 or something like that, and a 24,000, or that you're nearly thinking, oh, but this is ridiculous. Why are they actually giving me all of these options? But it might just be as simple as that it was in thousands of rand. So just again, be careful about that. Okay, the last one. So last one, they tell us, okay, the cost function of a factory that manufactures boxes of nougat bars is given by the cost function of 500 plus 5x, where x is the number of boxes of nougat bars produced. The factory cannot produce more than 2,000 boxes of nougat bars per day. So now they want us to the marginal cost function. So now you guys must check this one out. So calculate C100 or marginal cost of 100, 500, 1,000, and interpret the results. Okay, so what is your cost or your marginal cost function? Now this is an interesting one. So I'm seeing it as 5, because the first derivative of that will fall away, and then you only sit with 5. So then it doesn't matter, because there is no x, whether you produce 100, 500, or 1,000. This is a weird one. I will just go and check if this was right, because this tells me that when it doesn't matter which one of these you produce, it will not have an impact on your marginal cost function. So does that mean, in economic terms, doesn't matter if you produce 100, 500, 1,000, or 2,000 boxes, your marginal cost will stay 5. So you will always try to manufacture or produce the most number of boxes, because your marginal cost will not increase. Feels weird, because you nearly want to say, if it increases by 1, what your marginal cost will increase be, but yeah, this is an interesting one. I will just go and check if this is correct. Yeah, so that's why I'm also, so it might be a product that, sure, what can be a product? So it doesn't really make sense. So it feels more theoretical than anything else, but it might be something that is so high cost in starting up the engines, or nearly that the most of the cost is actually sitting in that fixed cost, um, that your fixed cost is so high, your variable cost is so small that it doesn't really matter. So that might be it. So really feels like more theoretical than anything else. Um, so that might also be that. So it's. I will just check what what this is and if this was correct, from a document I took this. But else this is purely theoretical than anything else. Um, because obviously then you will always go for the maximum for 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 the costing. Okay, so it might be that on the costing you yeah, so it might just be that from a costing point of view. So if you think of no-gut bars, that maybe that fixed cost already or includes your electricity, whatever is used to produce the nougat, might even be the foil or whatever it is in. Um, so then, like you say, it's nearly only the hours or the production line that nearly is, um, because it now can be that your total revenue might also be very low, that or it might be very high. So maybe just from a costing aspect, um, it might be great. I then want to be in this industry, because that seems like a very nice one to be in. So it will be actually. I'll just check if there was actually a follow-up on this, where they now give you a total revenue maybe as well, and then something weird pop out. So, but else very theoretical and not really. So it might be that you get something as this, um, because to test the theory behind it, but probably not likely. Okay, guys, that's it. So, Cole, you're making your 7 o'clock deadline. Um, so please, when you now, especially this week, take some of those, um, send some of those questions through that we can see what is in it. And then I will schedule for us um, our last 2 weeks of um, will nearly move away from the Monday so that you guys nearly can, when it opens up for those first few days, do the assignment, um, maybe then send me some of those assignment questions, and then around the first day, Friday or Saturday, we can work in a session and go through that. So when you do your final assessment in the last 2 weeks, when we have some prep work that we have done. Yeah, see, so that is, Alzette, I think that is your comment there is nearly spot on. So you will nearly want to stretch that, and it might be that when, again, like you said previously with your margins, that this is you go full out with your costing to push the limit to whatever it can handle, and that's how you nearly make the, the product valuable or affordable or something like that. Um, yeah, so, but I'll go and check again what this was and if it was correct. Yeah, so, but remember, practical and theory is also sometimes far divided. So yeah, so it might just be that I wanted to test the practical angle than anything else, um, and not really life, real life in this one. Okay, cool guys. I will share this, and please share some of the questions that you guys might get. I think what you will probably get in this assignment is normal ones to derive or do the derivatives of, and then you will get these these marginal cost, marginal revenue, and marginal profit ones. So and it can then take any format. It doesn't need to be a straight line. It can be a bit different for costing systems, so that when you need to work out marginal cost, it might be just a cube or a quadratic or something else. Okay, so good luck with the assignment, but then let's work towards the last two big ones of next week and the week after, so that we can get good marks in those two 40% or two 20% ones. Okay, have a good evening, and then we'll chat again sometime next week. Cheers, everyone.
Bye.
Bye.